Picture your local grocery store at 9 o'clock on a Sunday night. Walk down the produce aisle. Notice anything. Half the strawberries are marked down 50%. The organic lettuce looks tired. By tomorrow morning, most of it will be in a dumpster. Now multiply that scene by 35,000 stores across America. The number you get is $27 billion, thrown away every single year. Here's the twist nobody talks about. We've known how to solve this problem for a decade. The technology exists. Major chains have tested it. Some have even implemented it. So why are we still throwing away nearly 40% of our food supply? Welcome back to Human in the Loop. I'm Morgan Reeves. Today we're going deep on AI demand forecasting in grocery retail, a technology that promises to eliminate billions in waste while making your weekly shop cheaper. The timing matters because food prices jumped 25% between 2020 and 2024, and waste has become not just an environmental issue, but a political one. Consumers are furious about grocery bills, and retailers are caught between inflation they can't control and margins so thin they'd fit through a sheet of paper. AI looks like the answer. But we've heard that story before. The landscape looks like this. Americans throw away 219 pounds of food per person every year. That's $1,200 per household, walking straight from the fridge to the garbage. The grocery industry operates on margins between 1% and 2%, which means waste isn't just wasteful, it's existential. When 40% of your fruits and vegetables end up unsold, you can't stay in business without passing those costs to someone. That someone is you. The traditional approach to inventory management has been surprisingly primitive. Store managers look at last week's sales, adjust for weather, maybe account for a holiday, and place orders based on gut feeling refined over years of experience. The best managers develop an intuition for their communities. They know that rain on Saturday means more rotisserie chicken sales on Sunday. They remember that strawberries move faster when school's out, but intuition doesn't scale, and it definitely can't process the complexity of modern retail. Weather patterns, social media trends, local events, competitor promotions, seasonal preferences that vary block by block. The human brain wasn't built for multivariable optimization at that scale. Enter the machines. AI demand forecasting works by ingesting historical sales data going back years, sometimes decades. It layers in weather forecasts, local event calendars, social media sentiment, even traffic patterns. The algorithms identify correlations invisible to human analysis. They notice that sales of fresh basil spike 48 hours after food bloggers post pasta recipes. They catch the fact that organic milk sells differently in neighborhoods with high concentrations of young families versus retirees. They predict with eerie accuracy that a cold snap in Texas will increase soup sales in Minnesota 3 days later, because people see the news and start thinking comfort food. Walmart implemented its AI-powered system starting in 2019 and reported a 25% reduction in waste within 2 years. 25% of $27 billion is serious money. Kroger followed with a 15% reduction. The CEO, Rodney McMullen, went on record saying AI became a key factor in improving freshness levels while cutting losses. These aren't pilot programs or PR stunts. We're talking about companies that operate thousands of stores, moving billions of dollars in perishable goods. McKinsey ran the numbers and found that AI-driven forecasting could reduce inventory levels by 2 to 5% while maintaining the same service levels. For a typical grocery store doing $50 million in annual sales, that translates to $100,000 to $200,000 in savings. Gartner's analysis suggested waste reductions of 10 to 15%, worth $50,000 to $100,000 per location. Multiply across a chain of 500 stores, and you're looking at $50 to $100 million in recovered margin. For an industry where total profit might be 1 to 2% of revenue, that's transformational. Now here's what they're not telling you. Those impressive percentages from Walmart and Kroger, they came after investments measured in hundreds of millions of dollars. The technology itself is expensive. Training custom models, integrating with existing point-of-sale systems. building the data infrastructure to handle real-time inventory across thousands of SKUs. But the real cost isn't the software. It's the organizational change. You're asking store managers who've built careers on their personal judgment to trust an algorithm. You're retraining thousands of employees. You're accepting that the system will make mistakes, and some of those mistakes will be spectacular. The grocery industry has a graveyard full of technology solutions that were supposed to revolutionize operations. Remember RFID tags? They were going to eliminate manual inventory counts, provide real-time tracking, prevent theft, and spoilage. Walmart spent billions on RFID implementation starting in 2003. The problem wasn't the technology, it was the complexity of grocery retail. Liquids interfere with radio signals. Metal shelving creates dead zones. The tags added cost to every item, and someone still had to maintain the readers. By 2016, most chains had quietly scaled back their RFID ambitions. Automated ordering systems had a similar trajectory. In the 1990s and early 2000s, every major chain experimented with computer-driven reordering. The systems worked fine for shelf-stable products with predictable demand, but perishables broke them. An algorithm doesn't know that the organic strawberries in today's shipment are smaller than usual, which means customers will buy fewer of them. It can't see that the packaged salads are 2 days closer to expiration than normal, requiring aggressive markdowns. It doesn't understand that the store's demographic is shifting because a new apartment complex opened 6 blocks away, bringing younger shoppers who buy differently. Here's the historical parallel. Electronic trading in financial markets. In the 1990s, computerized trading systems promised to eliminate human error, reduce costs, and improve market efficiency. The bull case was overwhelming. Algorithms could process information faster, execute trades more precisely, and eliminate emotional decision-making. And they did all those things. But they also introduced new categories of failure. The flash crash of 2010 wiped out nearly $1 trillion in market value in 36 minutes. Because algorithms created a feedback loop nobody anticipated. The humans weren't better at trading, but they were better at recognizing when the game had changed. The difference today is computing power and machine learning sophistication. The AI systems running in 2025 aren't rigid rules-based programs. They're adaptive models that learn from mistakes, incorporate new data sources, and adjust to changing patterns without human intervention. When a TikTok video about a specific recipe goes viral, modern systems can detect the spike in engagement and adjust ordering for the ingredients within hours. When an unexpected cold front moves through, they don't just increase soup orders, they predict which specific varieties will sell based on that community's historical preferences during similar weather events. But that sophistication creates its own problems. The more complex the model, the harder it becomes to understand why it made a specific decision. Store managers can't interrogate the algorithm. When it recommends ordering 30% more Brussels sprouts than usual, do you trust it? What if it's picking up a pattern that's actually random noise? What if it's extrapolating from a trend that's about to reverse? The accountability question gets thorny fast. If the AI orders too much and you throw away $5,000 worth of produce, who takes responsibility? So what does this mean for you? The knowledge worker, the manager, the person actually navigating this shift. First, understand that grocery retail is the canary in the coal mine. It's one of the most complex demand forecasting problems in commerce, which makes it an ideal testing ground for AI systems. The lessons learned here will cascade into every industry that deals with perishable inventory, seasonal demand, or rapid shifts in consumer preference. That's hospitality, fashion, pharmaceuticals, and logistics. If you're managing people in any industry where forecasting matters, you need to develop what I'd call algorithm literacy, not coding skills, the ability to understand what AI can and can't do, where it adds value, where it introduces risk. The grocery chains succeeding with AI aren't just implementing software. They're teaching their teams to work alongside it. Store managers at Kroger don't blindly follow the system's recommendations. They review them, apply local knowledge, and provide feedback that improves future predictions. The human judgment hasn't been eliminated. it's been elevated to handling exceptions and edge cases. For founders and product people, the grocery waste problem illuminates something crucial about AI-driven solutions in traditional industries. The technology is rarely the bottleneck. Walmart and Kroger didn't need better algorithms. The math was already good enough. What they needed was change management, data infrastructure, and organizational buy-in. If you're building AI tools for industries with thin margins and complex operations, plan to spend more time on integration and training than on model development. The brilliant algorithm that nobody uses is worth exactly $0. The actionable takeaway for this week: identify the forecasting problem in your own work. Maybe you're estimating project timelines, predicting customer churn, or planning resource allocation. Take one decision you make regularly based on historical patterns and gut feeling, and actually map out the variables that influence it. Write them down, all of them. You'll probably identify 15 or 20 factors. Now ask yourself, could I actually process all of these simultaneously with appropriate weights? Almost certainly not. That's where AI adds value, not by replacing your judgment, but by handling the computational complexity while you focus on the context it can't see. Smart professionals in adjacent industries are already adapting these lessons. Restaurant chains are implementing similar demand forecasting to reduce food waste while improving menu availability. Fashion retailers are using AI to predict trend cycles and optimize inventory before markdowns become necessary. Pharmaceutical distributors are forecasting demand for medications with short shelf lives. The fundamental pattern is identical. Use AI to handle multivariable prediction, keep humans in the loop for contextual judgment and quality control, and accept that the transition period will be messy. The question from the opening isn't why we're still throwing away 40% of our food supply. It's why we thought the technology alone would solve it. We've had the algorithms for years. What we're finally building is the organizational capacity to use them well. Walmart's success came not from having better AI than competitors, but from committing to a multi-year transformation of how stores make decisions. Kroger's results came from retraining thousands of managers to work differently. The technology was necessary, but not sufficient. Here's my prediction. Within 3 years, every major grocery chain will run AI demand forecasting for perishables. But the waste reduction will be uneven. The winners will be the chains that invested in data infrastructure, change management, and algorithm literacy. The losers will be the ones that bought the software, flipped it on, and expected magic. The technology is real. The economic impact is real. But it still requires humans in the loop who understand both the possibilities and the limitations. The machines are getting better at prediction. We need to get better at working alongside them. That's Human in the Loop for today. I'm Morgan Reeves. Stay curious, stay adaptable.